Today we're going to be talking about 4.5. How the heck? Oh. 4.5, which is about direct, inverse, and joint variation. Okay? Those are the three things it's about. This is 4.5. Sure, label at the top of your page with that title. Now, direct, okay, is y equals kx, which basically means that y varies directly as x. Okay, in real world situations, k is positive. Okay, and as x, right now, real world situations, k is positive. As x increases, y increases. That's basically what that means. Okay, if it's not a real world situation, yes, k can be negative, but that's only in theoretical math. We'll talk about that here in a little bit again in the examples. Okay, k, on the other hand, and you can find that in the other video, k is equal then to y over x. If we solve for k, we have to divide both sides by x. That means that we have a ratio or a slope. Why put an exclamation point there? Ignore that. That was a typo. Okay. Now, over here, we have -1, 0, 1, and 2. We plug those in. 2 times -1 is -2. 2 times 0 is 0. 1 times 2 is 2. 2 times 2 is 4. Right? Pretty straightforward stuff. And then we plot it. This gives us a visual representation of the variation. Okay? So we've got it 0, 0, down 2, back 1, down 2. 1 over 2. Okay? So our variation is essentially going to be 2. Right? Rise over run. Now, what that means is that there will always be one intercept, and it'll be both x and y intercept, and that is 0, 0. If it's shifted left or right, it's not a variation. It has to go through the center point of the graph. Okay? Does that make sense to everybody? Yeah? This should be really easy. Okay? It's not too complicated. What makes it complicated is the wording. You need to make sure you know the language, because when we start throwing these in word problems, that's when you're going to start making mistakes, because you're going to forget who goes where and who does what. Keywords are critical here. All right? Now, let's talk about its contrast. In contrast, or comparison, or inverse, y equals k over x. Okay? Okay, so for that, y varies inversely sorry if I put E in there, as x, meaning that real world situations, when k is positive, of course, as x increases, y decreases. Meaning that for solving for k, we get x and y. Multiply x by both sides. That means it is a product. Now, when we do these, the points are going to get wonky. All right, let's take a look at some examples here. We got -4, -1, 1, and 2. We'll skip 0. You'll know why here in a second. But let's take those. If we plug them in, 2 over -4, we get -1/2. Okay, plug -1 in, we get 2. -2, sorry. Plug 1 in, we get 2. 2, we get 1. Yikes, that's not going to be fun to graph at all. There's no semblance of order there. Well, let's just plot them real quick and just see what happens. Okay, so we're going to go back 4, down 1/2. Going to go back 1, down 2. Going to go over 1, up 2. We're going to go over 2, up 1. Holy moly, I can't even get a straight line out of that. What the heck's going on? Well, let's graph it and find out.
Holy jeepers.
All right, so if we plug in 2 divided by x, okay, We go to second table. Scroll up a little bit. Okay, what in the world? What's going on here? Guys, we can't use 0. Why can't we use 0? Can you divide by 0? No. That's why. It is going to avoid any possible intercept of x come heck or high water. It will not touch it because it just won't work. Anything on the intercepts are out of the table. Poof, gone. Everything other than the intercepts, however, are fair game. And that is reflected in this crazy, kooky graph. This is a variation, inverse variation function. This is graphed variable fractions where the variable is in the denominator. We are not more so doing this to get the vocab. Also, we're not so much doing this just for the vocab. We're also doing this to show you guys a new graphed function when a variable is in the denominator. Going back to table, we can see what happens. Basically, it mirrors itself. If I were to get 0 locked on in the middle there, you can see it mirrors, okay? So basically we come back to here. That means we've got 4.5 up here. We've got 4.5 up here. We have -2, -1 here, another 4.5 here. And what you end up getting is a graph like so. With the asymptotes, remember what asymptote is? It's basically the invisible border that cannot be crossed by a line. Okay. And these asymptotes will always be the same for all variation functions, where x equals 0 and y equals 0. Now, let's talk about direct, inverse, joint, and combined. Direct and inverse is basically just the formal write-up of the sentence of what we just did up here. So, if you know one-ordered pair, x and y, in a given variation relationship, you can find the constant of the variation k and write the direct or inverse variation relationship. All right, so yes, relationship. Now, the next one is joint. When more than 2 variables are related directly, okay, we have y equals kxz, meaning that you have your grandpa, you, your cousin, and your second cousin removed. They're all related, but they're all different. That makes sense? Yeah. K is the constant. X will always be there, and then z is basically a modifier, if you will. Okay? You can have as many multipliers as you want on top of that. Because reality is, 2x times 2 is going to give you 4x. What they freaking do. Okay? Just increases the scale of the problem, or the function. Now, the last one is combined, where involves a combination of direct or joint variations and inverse variations, where y equals kxz over w. So now you have your grandpa, you, your cousin, your second cousin, and your stepbrother. All right? So there you go. Now, we're going to go over some examples. They'll be in the next video.